Okay, looking at the board, this is today's bell assignment. Please get working on this quietly at your seat. When you're finished, go to the board with your answer, and you can go over those as soon as everyone is done. Please pause it so that they can see the assignment. What we're talking about today is lesson 62, classifying triangles. Recall from lesson 7 that we classify triangles as acute angles, right angles, and obtuse angles. Remember that an acute angle is between 0 and 90 degrees, a right angle is equal to 90 degrees, and that an obtuse angle is greater than 90 but less than 180. We use the same words to describe triangles that contain these angles. If every angle of a triangle measures less than 90 degrees, then the triangle is an acute angle. If the triangle contains a 90-degree angle, then the triangle is a right triangle, excuse me. An obtuse triangle contains one angle that measures more than 90 degrees. And a good rule of thumb for this is that the triangle is classified by its largest angle measure. Okay? So if all of the angles in a triangle are acute, then the triangle is an acute triangle. If it has a 90-degree angle, it has to be a right triangle. And if it has an obtuse angle, it has to be an obtuse triangle. Here you can see that all of these angles in my acute triangle here are less than 90 degrees. The right triangle has a 90-degree angle, and the obtuse triangle has one obtuse angle. When describing triangles, we can refer to the sides and angles as opposite for each other. For example, we might say the side opposite the right angle is the longest side of a right triangle. The side opposite an angle is the side the angle opens towards. Okay, so the right triangle here, or the right angle here, opens towards this side. So that's the side that corresponds to that angle. And the right triangle side AB or line AB is the side opposite angle C. This is angle C, this is side AB. And angle C is opposite of side AB. The lengths of the sides of a triangle are in the same order as the measures of their opposite angles. This means that the longest side of the triangle is opposite the largest angle, and the shortest side is opposite the smallest angle. So here, this 90-degree angle is our largest angle. That means that this side is the longest side. The next biggest angle is angle B, which is opposite of side AC. So this is the second longest side. And angle A is the smallest angle, which means that this is the shortest side. They go in that order. Okay? Name the sides of this triangle in order from shortest to longest. Well, before we can do that, we need to know what all three of the angle measures are. We know that all of the angles of a triangle add up to be 180 degrees. So I know that W plus X plus Y has to equal 180 degrees. I don't know what W is. X is 60 degrees. Y is 61 degrees. And those added up have to be 180. So 60 plus 61 is 121. So W plus 121 degrees is equal to 180 degrees. I'm going to subtract 121 from both sides. Okay, so whenever I do that, I have to make sure that I cancel. And I'm left with just W, bring down my equal sign, and when I subtract those, I get 59 degrees. So I can substitute in here, I can label here 59 degrees for W. So the shortest side is going to correspond to the smallest angle. The smallest angle here is W, 59 degrees. So that means that side YX should be first. Then my next largest angle is 60 degrees. So the side opposite it is going to be the next longest angle. So I have that side YW is next, which means 61 degrees is the largest and line WX has to be the longest. So this is your order, 1, 2, and 3, from shortest to longest. Which sides of this triangle are the same length? Okay, so we need to know what angle Q is. Once again, Q plus R plus S has to equal 180 degrees. So we don't know Q. We know that R is 61 degrees, plus S, which is 58 degrees, has to equal 180 degrees. So we can now take 61 plus 58 to get us 119. Bring down our Q, our equal sign, our 180. To get Q by itself, we must subtract 119 from both sides. Whenever we do that, now we know that we can cancel. So we have that Q equals 61 degrees. So we can label Q 61 degrees. Well, now the two angles that are congruent, or that are the same, are 61 and 61. So the sides that are the same length are going to be the sides that correspond to those angles. So we have side SQ and side SR. Final answer. In triangle JKL, JK equals KL equals LJ. Find the measure of J. So we know here that these are all equal. We know that JK equals KL, which equals LJ. Well, if all of the sides are equal, that means that all of the angles have to be equal too. So I have three angles that are all the same. That means that I have three, something is their measure, and those three angles have to always equal 180 degrees. Now, 3 is being multiplied by x. I want to get x by itself, so the opposite will be to divide by 3. What I do to one side, I must do to the other. 3 and 3 will cancel, leaving me with x equals 60 degrees. Final answer. The triangle in example 3 is a regular triangle. We usually call a regular triangle an equilateral triangle. As shown below, three angles of an equilateral triangle each measure 60 degrees, and the three sides are the same length. The tick mark on the sides indicates each side of The tick marks on the sides indicate sides of equal length, while tick marks on the arcs indicate angles of equal measures. So they show us here our equilateral triangle, and these tick marks mean if it has two tick marks, anywhere else there are two tick marks, it has to be the same. On the angles where there's one tick mark, those have to be the same. So an equilateral triangle has three equal sides and three equal angles. If a triangle has at least two sides of the same length and thus two angles of the same measure, the triangle is called an isosceles triangle. The triangle in example 2 is an isosceles triangle, as are each of these triangles. Okay, so these are three examples of isosceles triangles. We have the first one where we have 70 and 70. Those are two equal angles, which means that their sides are also equal, so we could just put tick marks there. Okay, then I have 45 and 45 being the same, so I can say that their sides are equal, so I could put tick marks to show that. And then I have 40 and 40, which means that their sides are equal, so I can put tick marks and tick marks to show that. Okay, so for it to be an isosceles triangle, it has to have at least two sides that have the same length and at least two angles that have the same measure. If three sides of a triangle are all different lengths and thus the angles are all different measures, then the triangle is a scaling triangle. So that means that it has nothing that is the same in it. All the sides are different lengths, all the angles are different measures. Example 4. The perimeter of an equilateral triangle is 2 feet. How many inches long is each side? Well, first of all, an equilateral triangle, equal means that all the sides are equal. So I'm going to draw us a nice triangle here. Okay, so this is my triangle. And I know that all of these sides are the same. And I want to know how many inches long each side is. Before I can do that, I need to know how many inches 2 feet is. Remember, we talked the other day about using unit multipliers to convert. So if I have 2 feet, that's my given that I'm trying to change, I automatically put it over 1. To convert it, excuse me please, to convert it, I'm going to multiply by a unit multiplier. I want to cancel feet. Feet's in the top here, so it must be in the bottom here. And I'm changing it to inches. So inches goes, whoops, I just put 12. So inches has to go on the top. Please remember that we have to have them in opposite places in order for those units to cancel. We know that 12 inches is equal to 1 foot, so feet and feet will cancel. Leave me with 2 times 12 inches, which is 24 inches. Well, all the sides of this triangle are the same length, and there are 3 sides. So I know that those 3 sides has to equal 24 inches. To get S by itself, I'm going to divide by 3. What I do to one side, I must do to the other. So I'm left with S equals 8 inches. Final answer. Example 5 wants us to draw an isosceles right triangle. Remember, for it to be an isosceles triangle, it has to have at least 2 equal angles and 2 equal sides. And for it to be a right triangle, it has to have a right angle. So, an example would be, here's my right angle. My 2 sides are the same, are this side and this side. Okay, it's not perfect because I'm not a great artist here. But there's you an example. And you're obviously not all going to have perfect triangles either. The tick marks are what tells us that they are equal to each other. So that's what, on your homework, whenever we go through and grade it, those are the things that are going to tell us that you know that it has to have 2 equal sides. Homework is lesson 62, A through F, 1 through 9 odd, and 12 through 25. Please make sure this gets on the assignment board. Please make sure that you are working quietly and individually. Please remember to read the, what's it called? Working lunch list. If you're on the working lunch list, make sure you go whenever Ms. Hodges' students arrive. Work quietly, no talking. Please be good.